So with that, I'm going to turn it over to Tom, and Tom, you have to clear this microphone. Round of applause for Tom.
Hopefully this will stay working and won't stop. So welcome everyone. As we mentioned, my name is Tom Doan. I've spent the past probably 8+ years doing cloud security. I was at a company called Sky High Networks, CASB. We did that whole kind of runway through there. This is going to die. And then for the past year, I've been doing cloud security in containerized, orchestrated environments. And we're going to talk about that today. You don't have to know what that means, but really what I'm going to talk about today is cloud native, orchestration, containers. Anyone hear the word orchestrator or containers when they're at work? Is this something that's top of mind? Anyone hear the word Kubernetes at work? All right, we got a handful. All right, so we're going to be kind of going through there's an evolution that's kind of happened in cloud. What we first did was we took all our servers on-prem, we moved them to the cloud, like Windows servers, virtual machines, you name it, and we're in the cloud. It's great, and we worried about security and everything else. The past couple of years, orchestration and cloud native has really taken root and changed. And we're not just moving servers anymore, we're rebuilding the applications in a cloud native way. And it's really pivotal to cloud security. It's really pivotal to what happens with the CSA. I worked with the CSA with Jim when it first started because we did the cloud vetting of cloud services and figured out to see the evolution that's happened just in about 8 years. It's just astronomical to see what's happened. So first up, the question that I get from a lot of CISOs and a lot of people that run security for their companies, DevOps people, you name it, is why do we do cloud native? Why do we care about cloud native? What is it? One of my first customers was GE Transportation last year at a company called StackRox, who did containerized Kubernetes security. He said when he took his application from monolithic to cloud native, his Amazon spend went from 10 million to 2 million a year. So just cost alone, you can be a complete hero if you can just figure out how to take an application that's monolithic, old school application, move it to the cloud, but modernize it and make it cloud native. The reason that spend went down is when you move to a cloud native application, you separate the application from, excuse me, speak up there. Okay. You separate the application from the workload that's running it. And when you can decouple the application from what's running it, now I can independently scale up and down my workload or my horsepower, which would be the containers, and the application stays steady. If 1,000 people log into it, I can add more containers. If they leave, I can remove them. That's really the genesis of cloud native, and that's the genesis of what we're trying to do. There's kind of 4 tenets to it. We used to have a DevOps workflow. Is anyone here familiar with the DevOps workflow or heard about that? Okay, that's very good. So the DevOps workflow is important. It needs to be API based. So when I talk to people, I always say, ask your vendor, is your application that you're trying to sell me, is it for security or whatever it is? It could be whatever application that's in the cloud or is cloud native. Is your application cloud native? If they say what's cloud native, you probably need to find a different vendor or at least really dig into is there a really good reason why it can't be or shouldn't be there. Probably every SaaS provider that we're using today is cloud native. So you talk about SAP, Facebook, name an app, ServiceNow that we're using, they're cloud native. They've been cloud native for a while. So that's kind of the first question that should be is, what am I using? What's your approach like? Are you using that? Now internally for the apps that we build or the apps that we run, we want to kind of move them there, but it's hard because a lot of these apps are legacy. We have a lot of stuff that's left on servers or that we want to move to the cloud. So getting in the cloud is one thing, but you want to start talking about, can we have a DevOps pipeline? Can we use containers for it? And the reason is the spend that you're going to get there, the hybrid ability. So the other core thing is, if I move everything to Amazon and I use Amazon services and I'm locked into them, that's awesome, but now I might be spending more than was on-prem and everyone says, why do we move to the cloud? I don't have control anymore and I'm locked into this cloud provider. So a lot of corporations were like, how do I get out of this? Great, now I'm in the same boat. I have to do a forklift to go to Microsoft or a forklift to go to Google. Now I'm locked into Amazon. If I choose a cloud native approach, when I go to an application, I can move that workload to that application. I can hybrid it. I can even let it be on-prem and in the cloud. I can move it to Google. So now we can do what's the best cost for our company, what's the best secure, and we can start moving our workloads around. That's a huge reason why people would want to go through the work of, I want to use cloud native stuff and I want to use those workloads. And then, really the always on is a totally different breed. I was on the phone with the gal who runs Sprint. I was doing a proof of concept with them, and she said the hardest thing for them to get around their head was that servers are no longer exist, and the applications are no longer where they used to live, and the rule is destroy the application to fix it. And that's what the new work, and when you're cloud native, and there's an orchestrator orchestrating the containers, to fix something, you just blow away the application, the orchestrator will automatically build a clean one, and you never go down, and the app never goes down. There's always replicas, it's always working. And everyone has their mindset of, you never break the app, you always let the app go, and it's really hard to get that around people. But once you get there, it's like this freedom thing for developers, right? Because I no longer have to worry about servers, I no longer think about anything, I'm just thinking about the deployment. And so going forward today, when I say deployment, I mean application. Those are synonymous with each other. When we're talking cloud native, we don't call them apps anymore, we call them deployments. That's kind of this new world that we're working into. Sure. Okay, you run it? All right, cool. Is it hot in here?
It's very hot.
Just me. All right. Is this better for you guys to hear me? Come up over here?
Yeah.
All right. So the next thing I want to talk about is, so what does it look like? So if I have an application, it could be, and all of us, any company is going to have applications that you own, stuff that runs on servers, you're going to have stuff you buy from people. So when we say move it from monolithic to a cloud native, it means we need to retool that application and break it into pieces, and those pieces run on the orchestrated cloud environments. So now we don't have a single thing that goes down anymore. A really crude example is shopping cart is no longer a part of this giant app. The shopping's just a little service that runs, and we fix that service, the application's still running. That's why we don't really get sites down anymore or services. It's just the button might not work, and it's because that service has something being fixed on it, but not the application. So that's what we mean when we're moving something from monolithic to cloud native. Anyone heard that word thrown around in monolithic to cloud native? Anyone heard that? Mark, you don't count. You definitely count in the back. So that's a word that you're going to hear a lot. This is coming out. Everyone that I talked to in the past year, they're all talking about how do we move all our stuff from monolithic to cloud native. That's the phrase that people have been using. Go to the next slide. So this is a lot of stuff. You don't have to know anything on here. This is just to bring some vocabulary to your attention. When we say the word Kubernetes, so a couple people knew about Kubernetes. Kubernetes is simply Greek for captain. That's all it is. Some geeks at Google, very smart people at Google, got together, invented this thing to orchestrate their containers because human beings wouldn't be able to do it. They run 2 billion nodes on it. The entire Google runs on this orchestration called Kubernetes. 3 or 4 years ago, they said, we've used it long enough, we'll give it to the world, we'll open source it. Once they open sourced it, Amazon built a service around it, cloud service around it, Microsoft and Google. So when we say containers, we don't really mean containers, we mean they're running in some sort of orchestration. They're running in Amazon EKS, they're running on Microsoft AKS or Google GKE. Those are the environments they run in. Now if somebody comes to you and says, hey, we're gonna build new thing on containers and we're gonna use ECS, which is Amazon's proprietary, it's gonna die in a year. No one is using it anymore. Amazon tried to build their own proprietary to compete with Google. As soon as Google open sourced theirs, everyone said, we'll move over to that. So the whole world is moving towards a thing called Kubernetes. It just isn't called that. It's called OpenShift, or it's called Amazon EKS. They're all cloud native. That's what we mean by containerized. The reason that the orchestrator is critical is if I break the app up into a bunch of parts and then I want to go manage this, it's impossible to manage. It's hard enough to manage a monolithic server. Imagine breaking it up into 1 million parts and trying to manage those. It would be 10 times harder to run your app. So nobody is running an app on containers without an orchestrator because I need something to build the deployment, something to keep track of it, something to run it. So if you hear someone saying, no, we don't use orchestration, then they're not really using cloud native yet, they're just dabbling. They're just putting a few things on here and there. If you hear the word Docker, Docker is the engine for Kubernetes. That doesn't mean you're using an orchestrator, that just means Docker is the runtime, kind of like Linux. This slide is up. There is a website or an organization called Cloud Native Foundation. Nothing to do with what CSA does and their security and their approach to cloud. all CNCF does is they keep track of these projects, like open source projects, like Istio and others. They host the Kubernetes project. Kubernetes is almost surpassing Linux in terms of volume and activity. So you have an open source project that's almost surpassing Linux. I guarantee you, 2 years from now, everyone is going to be running some sort of orchestrated, they are on the West Coast, they are on the East Coast, everyone's going to be running some sort of Kubernetes-based orchestrated workload somewhere. It'll either be you've moved your monolithic applications over to it, or your vendors are now telling you this is how we deliver it. That's how things are being delivered now, is on a orchestrated workload, and it's going to be one of those services. So it's growing faster than you can imagine. It went from, in 3 years, being 0 to 95% of all orchestrated workloads are now on some sort of Kubernetes version. So it's back in the old days. I've been doing this since the 90s. I used to ask people when I owned my own consulting business, are you on SunOS, Iris, or BSD, or Linux? I'd ask them what flavor of Unix they're on. I don't ask them that anymore. It's Linux, right? That Linux won the war. This is going to win the war for the operating system for the cloud. So the cloud is going to be operated with, it's kind of like this operating system. So that's kind of where it's going. Go to the next one. Everyone hearing me okay so far? That's good? If you guys have questions, please stop me if you want to ask questions in the middle of this. So this is the architecture of an orchestrated cloud native workload. And I'm not going to go and explain all these details. I want to explain to everyone how complicated it is and why it's hard to explain. It's very hard to get through these processes. And when somebody says, I have container security, and they don't have deployment aware security, they're not aware of the deployment, it's like saying, I'm going to secure the water that your boat is floating over. I'm going to make that puddle of water it's insecure. Every 5 seconds it's moving to a new puddle. There's no way you can secure the containers. You have to secure the deployment. The boat is the deployment, the water is the containers, right? The average container lives less than a day. So the orchestrators, this cloud native orchestrated environments, they are destroying and rebuilding the containers every day. There are thousands of them, and they're irrelevant. The containers have no meaning to anything. They're supposed to be there just to serve workloads, and that's the whole point of it. So the really important part for security is I need to be able to describe my application or my deployment, otherwise I can't secure it. If I try to fix one container and it's gone in a minute, I'm not doing security, I'm just, and I've seen people try to do security to go, we ran it on all your containers and all these are out of compliance. Well, I have no idea what applications they're associated with, and I have no idea if they're even going to live tomorrow. So it's really hard to get compliance with that. I have to get compliance. Auditors don't come to you and say, can you make that container compliant for me? They go, no, that healthcare app, you need to prove to me that healthcare app is compliant. So that's kind of how they think. So this is kind of how it looks. And the thing to the left, if it's hard, can you guys see in the back? The thing to the left is the orchestrator. So it's directing the deployments. It's in charge of the deployments and it's running it. The thing on the right would be the nodes. A node, vocabulary-wise, a node is the old physical host. So if I have an actual server, that's a node and it runs containers on it. If I'm in a cloud environment, that would be a virtual machine would be a node, and that would be the worker nodes. Now if it's a managed orchestrated, like EKS on Amazon or AKS on Microsoft, you don't really know what's going on there. They just go, here's your node and you get it. But in our world of what we think about, it's a physical server, right? It's that old server that it could be virtualized or it could be there. And on that node is where my workloads run, and that's where my stuff's happening. So I could have 4 nodes and I could be running 1,000 apps. I could have 4 nodes and run 2 apps. Depends on how big the apps are and how much I want to work, how much I want to push on them. If you go to the next one. So what this is showing you an application or a deployment running on one of those nodes. So there's a cluster. We call them clusters. It's a word that you're going to hear. But all this is showing you is that WordPress, anyone heard of WordPress? It's a good example for an application, right? So in that WordPress application, the containers are right here. So these containers are all being blown away and replicated and all that stuff. As you can see, security on the containers would be the smallest part of all the stuff that's going on there. It's very little of what's happening. Now you can loosely try to describe where your app is running, but you know the things that are running on that container, where they're associated with. So there are some legacy apps out there that will say, well, we saw 55 instances that said WordPress on them, so maybe that's WordPress, but they're going to float in and out all the time. But this is kind of how it looks in the world. That deployment is what we care about. There's 2 different schools. There is products that were created before there was orchestrators, and there's products that were created after. So anything created before Kubernetes three years ago was out, all we can do is really secure these containers. And I'm going to talk about there's really good hygiene to do in those containers. There is vulnerability, there's stuff we can do, and we have a whole slide to talk about that a little bit later. But all you have visibility to is just this very small work part of it if I was born or my architecture was before that. Now, they're all playing catch up and they're re-architecting, but in your mind, when you're talking to people and you're talking about security, say that's great that you have container security. Can you describe my deployments to me and secure my deployments? Or can you just secure the containers? And if they're completely like, I have no idea what you're talking about, they probably don't have something that's going to be useful for you. There is products out there that can give you security by deployment, and those are the ones that you need because it's really critical to how you do it. Any questions? Does this make sense so far as to how this works? There is a captain called Kubernetes, is Greek for captain, that directs these deployments, and it's in charge of where things go, and it's just going to grab what it needs to serve that application, and it doesn't care what it's grabbing. It's going to be providing more workload containers if it needs more, and destroying them if they don't need them, and keep replicas around. That's kind of how it works. Next slide. So, sure.
Can we get questions now?
Yeah, you can take questions. That's fine.
So on the slide where you had the
Yep.
what's the best way to translate that? Just starting, the middle, or get breaking down?
So the question is, on the monolithic to cloud native transition, what is the trend? You know, what's out there? It depends on your business right now. So if your business is extremely scalable, where you have a lot of load and you're serving maybe consumers, or you're serving some sort of really high-end utilization, those companies are already there or moving there, right? So even the automotive, that, you know, we have a lot of automotive here, a lot of others. If there's applications like autonomous cars where I'm going to have an incredible amount of workload, those kind of things are all cloud native or all been moved over. Where it's a little bit of stagnation, and this is kind of where a lot of these legacy apps that we have, unless if there's a good reason to rip it out and tear it apart and move it into and rebuild all the code to it, people aren't doing it. So in the Midwest, there's a lot of, we're just starting to do it. So State of Michigan is one of my first customers. They just built a whole cloud native cluster, and they're building those things. They're getting into it. There is people that are doing it, right, that have apps in it, but it's not from 150 meetings last year, about 10% have really embraced and moved it to some sort of cloud native workload. The rest we're just starting to do it now. So we're just building our environments. Maybe it's in Amazon, maybe it's in Microsoft. We're just now getting our developers to have access to it. And there's a bunch of domains that they need to learn. They need to learn how to do DevOps. They need to learn how to do, how to get my pipeline to work, right? All those things are kind of learning stuff. And so I would say actually I did do an analysis of it, and it was about 10% that was there versus the people I met with. I live in Michigan. I meet with people in Ohio, Michigan, Minneapolis, the Midwest, right? And that's about in the Midwest where it's at. That's very anecdotal, but that's just my experience. Go to the next, Bill. Just build the slide out. So just as a visual in your mind, the left is, if I have a product that only sees containers, my security is very limited. I don't see the thing that's creating them. And it's just a different visual than the last slide. It's just, think about, you're in the dark, you're trying to fix things, but you have no idea what you're fixing, so you're fixing it, and it's really hard to keep track of it. And that's the difference between the two different types of solutions. Go to the next slide. Build this all the way out. Okay. So I mentioned shift left earlier. A couple people raised their hands, right? I heard the shift left thing before. So security as code, shift left, these are kind of buzzwords that the C-suite or the CISO security people are all throwing around. What we mean by shift left is, instead of letting someone, just to back up, this slide right here, this is the DevOps pipeline. So are we going to be able to share these slides, Rob or Earl, afterwards? So this is your DevOps pipeline. And the first part of a developer or DevOps pipeline is we don't build software that we install. We don't manually install apps anymore. We create an image repository, which I'm sure most of you guys out there have some sort of image repository for your builds. And what we do is, in those builds, we need to make sure that when I'm building it, I don't use stuff that's vulnerability. I don't build it with things that are vulnerable and those kind of things, right? The shift left means instead of letting security happen after I built it, after I deployed it, and now I'm running it, and then we go look at security, security needs to go all the way to the very front. And when I'm building software, I need to make sure I build it without any vulnerabilities in it. And so that's how the developers now are part of your security team. They are part of the security. The way to get them on board is to find a tool that doesn't let them go forward in their process until they do the stuff you want them to do. So you want to have some sort of control over it. So if they want to check in their build for whatever application that they're fixing, and they used copy instead of add, and one is less secure than the other in terms of best practices, and we got together in a room and said this is our best practice, you want it in that application they're using, and that's why Jenkins, I don't know if you've heard of that, or Travis, there's a lot of build tools out there. Whatever the developer's using, I want to stop them in that application and say, I'm sorry, we want you to do it this way. Here's an example of how to do it. As soon as you fix it, you can go forward. There's a lot of tools out there that can help with that, but that's the kind of security we want. Any question?
How is it different from Agile?
Agile is another build tool, build pipeline tool. Agile is more of a philosophy, right? Agile is a way to do things. So this is like Agile. But it's a DevOps practice. So Agile would be your DevOps process, right? Be your practice. So the question is, what's your DevOps practice? We're an Agile shop, right? It's just how we do it. And so the security is, we want to make sure that before we build it, we build it with good stuff. Now, just because I have a really safe car doesn't mean that car can't be taken out and something really unsafe done with it, right? We can do something really dangerous with the safe thing. So having that first check is great, but it needs to be more than just that. The immaturity of the market, really, and I'll talk about this a little bit, is really stuck in the very first part of the shift left. But when we get into the deploy, and we're deploying stuff, we want to do things like, did you deploy it with the ports open? That's the traditional, like an application. Did I leave the ports open? Did I not check things? Did I leave holes that people could hack? That's the deployment. And then the run phase is, it's running, that application is out the door, and now we have to do normal threat hunting, and we have to make sure that application isn't compromised. So the three things that you're going to hear, and this is inside the orchestrated vocabulary. So the Kubernetes orchestrator or the Amazon or Microsoft, whatever you're using, it actually calls it build, it calls it deploy, and it calls it run. So these aren't words that we use. Your developers are, I got to build this, and it's in my build phase. Your developers have to go deploy it, and it's called deploy, and it's called run. So this is how the actual names are that we're running these deployments, and that's how it's run. So we can come back to that later, but these are the tools that people use. So anyone here ever heard of Tenable? Or one of those are vulnerability scanners. That's shift left. That's scanning the images and making sure they're not vulnerable. And then in the secrets management, anyone ever heard of Vault or AWS Secrets Manager or any of those kind of things? That's what we use to manage the secrets. And then when it comes into the runtime, we have the Docker runtime. There's a new runtime called Cryo. Doesn't matter to you guys. It's just the engine that thing's running on. And then we get to the far left, what's orchestrating that. And then all the way to the right is what notification tool to use. Do you guys use PagerDuty, or do you use ServiceNow? You know, what do you use to notify your developers that, hey, I want you to do this, or I want you to do that? What do you use for your security team? You know, what do we want to, if there's something that's compromised, I want to notify the security team, how do I do it, right? Do we use Splunk? Do we use those kind of things? So that's what a DevOps pipeline looks like. Agile could be the practice, right, that you use for it, but that's the tools, or typical tools. Any questions before I move on? Okay, next. So I'm going to talk about 4 core use cases. That's the majority of the talk today. And the 4 use cases are, 1, we've already talked about vulnerability scanning. So that's scanning the entire ocean. So I'm going to go through the whole ocean. I'm going to filter all the water and make sure that there's no bad stuff in it. That's vulnerability scanning. That's kind of how we think of it. The second core use case is control over the process of deploying these applications, building these applications, and running them. So that's policy control. I'm an old DLP person. I'm formerly at Symantec and McAfee, and now I'm at a company called CrowdStrike. DLP is near and dear to my heart. DLP is very much the same idea when it comes to controlling this security process. When we're doing these like DevOps applications and we're deploying them, it's the same thing. I need to have a policy that says, if it's going to be in my production and it has this running on it, and this port's open, I want to stop someone from going forward. It's the same kind of rules of I need rules of engagement. I want to make sure I can control those rules of engagement. So that's kind of what that use case is. The third use case is critical. All of us here are familiar with DMZ, old school, got a firewall, put my stuff in the DMZ, my application. I want to make sure that it's not, we wouldn't put a healthcare app and a payment app in a DMZ and leave them wide open, right? Nobody would do that, security. So when I put two applications in a cloud workload cluster, by default, they're open and we can talk back and forth to those applications. So by default, they can just talk and do whatever they want between them. Because I might have one service that feeds a bunch of other services, so they need to kind of be open. But as a security person, the first thing we need to do as security folks is, I need to go in there and segment these apps so they can only do what they're allowed to do, which is what we do in a DMZ. So when we say network segmentation in a cloud native world, we really mean old school in my mind, that old DMZ. I want to make sure my apps can only do what they're allowed to do and aren't allowed to, we call it the blast radius. If somebody gets into one thing, they can't go any farther than that application. And that's how we want to control this. It's called network segmentation. We're going to talk about that. And then finally, the fourth thing we're going to talk about is compliance. Compliance is a very challenging subject for a great deal of vendors and companies, right? It's very challenging to get through. What we mean by compliance is, do you have a requirement for a PCI? Do you have to, or does your app have a HIPAA if you're in healthcare? Or it could be you don't have a compliance requirement, but you want to be at least to the benchmark, so you could say to your manager or whoever you work for, we are Center for Internet Security benchmark compliant in our Docker and our orchestrated workloads, and here's the proof, and as of today, here's the report of we're totally there. Now, what goes beyond is the audit folks and the security folks, they don't care about the whole ocean, because you might have a sandbox that isn't going to be compliant, and you might have a production environment that is, and you might have different production environments. What we need to do as security folks is say, this application is compliant, and here's my evidence for the application. So compliance needs to be done. We need to go a step deeper and be able to, just like we used to be able to do. We used to run compliance, we'd go to the server, we'd run a report on it, we'd go, here you go, no one's ever connected to it, we're good. So we need to get that back, and there's ways to do it. So go ahead to the next one. Okay. So the first use case we're going to talk about is vulnerability. Anyone here done vulnerability scanning or heard about it at work or worked with vulnerability? Okay. Vulnerability scanning is critical to, I call it the first leg of security, right? Let's not use Apache struts, let's not use malware and leave it in a library that our developers can go grab at any time and deploy, right? Let's make sure that everything in our repository of applications is at least clean as of today. Because tomorrow, what's clean today might be vulnerable tomorrow, because they come out every day. So vulnerability scanning is done on a regular basis, it's continuous, it never stops, and it's point in time. So as of this point in time, we scan everything and we're clean. And there will always be tons of vulnerabilities in your image repository. So so you're using Google's or Amazon's, Microsoft has one that you can utilize and put your applications in there. There's always going to be vulnerabilities there. The hard part is, what do I need to fix and what do I not need to fix? Because you're not going to be able to fix the whole world. What you're going to do is you're going to fix the applications you're running, the fact that you care about, and you only need to fix the images you're using. So vulnerability scanning, what's important here is ask for vulnerability scanning, but make sure that it can describe the applications and how they're running beyond just boiling the ocean. Can you show me where all my ships are in the ocean and make sure that those at least don't have vulnerabilities? And maybe I'm only going to fix those first because I don't care about the whole ocean. There is dangerous parts of it, but I care about my ships where they are. And so really when you think about vulnerability scanning, it's what do I have to do and what's most important? When we hear about breaches, it's always they had a tool and they could have seen it, but there was so much to do, they just missed it, and they missed it for a really long time. So it's always context, and context of vulnerability is everything. This slide right here, go back one. Yeah, so this slide right here, this is a product called StatRox, and this is just one application. So it's showing in this one application the images it's using, where it's deployed, which ones are fixable, which ones aren't. If you just fix this one, 80% of the application will be fixed. This is how you need to fix stuff. There's other tools out there, there's Sysdig, there's other ones out there that can do kind of like this. This is probably one of the best ones. But that's the litmus test that you need to ask for. Can you tell me where my vulnerabilities are in my deployments? Deployments equals applications. not just tell me what my vulnerabilities are. And that's really the next level where you need to get to. So the idea is I need to understand the impact of my environment. I need to understand what clusters it's running. And then the underlying, if it's managed, you don't have to worry about it because that's what Amazon does for you in the cloud. But if you're doing some sort of hybrid cloud environment, you'd have to make sure the vulnerabilities of that running workload aren't there as well. So there's a lot of places to search for it. There are some open source tools. There's one called Claire, which is a really good vulnerability scanner. This right here is really Claire. So all StackRox does is put a graphical interface around an open source tool. So it's not something that's really magic. It's just, there's a couple of good open source. Tenable's a really good kind of commercial one if you want to buy a commercial vulnerability scanner. There's original players, Aqua, Twistlock that you probably heard of, and just Palo Alto just bought Twistlock. They do vulnerability scanning. That's kind of a core, like, we're at the table and we're going to do this and this is where we start, right? It's kind of the first thing that we talk about. Go to the next slide. So this use case is about, and this is just an example of how to do it. This is a StackRox capabilities. No way you guys are going to read this. I'm going to talk through it and show you what they're doing, right? So in each phase of my deployment, or each phase of my application lifecycle, I want to do vastly different things in different teams. So we might have a threat hunting team that is this run right here. This is where my threat hunting team cares about. And so instead of saying, I want to secure the containers, your threat hunting team is going to say, we need to make sure that we have visibility into your running deployments, and we want to make sure that we know there's no compromises, there's no attacks. A great story, anyone here hear about the Tesla hack that happened on their orchestrated environment? This is a fun one. So one of the developer guys decided that the dashboard for Kubernetes is cool, so he turned it on. Had a vulnerability in it, it was just open. Hacker immediately found it. They immediately started doing crypto mining, crypto mining on all of their servers. They ended up taking almost all of their resources mining cryptocurrency on all of Tesla's horsepower, and they didn't even catch them for a very long time because they weren't stealing anything. They were just stealing while they were making money, right? They were stealing all their horsepower, which they had tons of. And so that's a running application. That's where threat hunting is critical. We need to have something that says, somebody just installed Shell and started running something, we need to stop that. So the policies in the very bottom are things like, somebody just ran Netcat and started looking through your network, or somebody started mapping, connectivity in there, and that's really bad. You need to have something that's automatically looking for these. You guys need to set the policies. There's a product called Falco from Sysdig. There's StackRox is what you see here. There is a policy, open source called OPA now, which is part of the EKS and Amazon and others. They're kind of hard to use. It's worthwhile to buy something that's a tool to use. Back to the DOP days, whoever has the easiest to use engine, you're going to use, right? If it's really hard, you won't use it. But those are the things that you need to care about. And that team is totally different than the folks that are talking about the deployment. The deployment would be the app owners, right? So whoever owns that application, they're going to deploy it, and you're going to say to the app owners, well, when you deploy it, I want to make sure that you put resource limits, because if you write an infinite loop, you're going to take down everything that we have, and we're going to go down. So those are the kind of things that we need to care about and think about. Forget about containers, forget about cloud, everything. If you have an application you install on an old server, just monolithic, there's all sorts of things you care about as security people. The same rules apply to a cloud orchestrated containerized workload. There's a million containers, so we have to secure it by talking to the thing that's building the application and saying, I want to be a traffic cop to this orchestrator that's orchestrating all these workloads. I want to set a policy engine that it looks to, and I want to have the rules, and I want to control what that thing's doing. So there's probably 20 or 30 rules that are built into the StackRox. They're built from customers like Splunk or others going, hey, when we go to deploy things, people aren't allowed to do this because someone got attacked, or people shouldn't leave the shell open, or they shouldn't do this. All these policies, you need to have control over that deploy phase. And so we say deploy is just deploying the application. And then finally, the build we've talked about. The build could be you have a vulnerability score of 7 or higher, and you're trying to build this image. So the vulnerability scanner says that part is bad. Fix that part, and you can complete the build. So you want to have control, you want to have visibility. So you need to have visibility to this, and you need to have control. Many things we don't control, but we want to notify and we want to know about it. So it could be just best practice, like something that's good that you want us to do. I don't want to stop people, but maybe I have a wall of shame on Slack that says, Bob did it again, or Stan, or whoever, or Tom did it again. So that's what you want to do for the kind of those phases of it. Any questions about the run, deploy, build, or build, deploy, run policy? Everyone get that? That it's really just you having the ability to describe what you want and enforcing it in your environment, and that's good security. So, okay, next one. All right, so network segmentation. Network segmentation is what we talked about earlier. This is actually, the way it works is this is a YAML file. The YAML file is a text file that describes what that deployment is allowed to talk to. So all it says is, this port's open, it can communicate out to the internet, or it can't communicate. It's very much like a firewall rule we would do in a traditional firewall. On the outside of my cloud native workload is a traditional firewall. So if you have a load balancer, typically it's just a traditional load balancer, F5, whatever. The cloud providers have their own load balancers on the outside of this cluster. But inside that, I have all these applications that can talk to each other, and we need to make sure that they can't do things they're not supposed to. So this particular tool here will actually watch. This is a payments application, and this is an operations application. It watches what happens, and then it'll automatically build a file for you. There's a bunch of tools out there that will do it. There's Tigera and some others. I think GM's using Tigera, or maybe there's a lot out there that people are using, at least that we think. But these tools here, all they do is give you a visual tool to see what's happening, and then you can use the native functionality that's built into the orchestrator to segment it. There is a lot of tools out there. There's a product called NuVector and others where they built their own proxy. What they did was they said, we're going to make a shim in between every container, and we'll force all that traffic through these shims, and then we'll do the network control. The problem with those is, and this is over and over, I've met with people, they don't deploy it because it doesn't scale and it breaks the applications. If it doesn't know about the thing that's building the apps, it's going to block a connection to a container that was being used for a database call, and now I'm going to break half of that app, and I'm going to break the database, and it may be running, but the app's broken. So you don't want something that's outside of that orchestrator. You just want to tell that orchestrator, here's how you segment those apps, and you just need to do it. We can do it manually. You can open that text file and manually edit it, or get a tool that visualizes it for you so it's easier. That's all network segment is. Network segmentation is just stopping one thing from talking to another thing so that we can make sure that they're safe. The word in security is blast radius. If I crack into one of the containers in your environment, I don't want to be able to go everywhere and blast the whole world and steal all your stuff. I just want to be locked into the jail of wherever I got broken into, right? I want to be in that little trap thing, and then we'll find it. Any questions about network segmentation? This is critical. SAP, this is one of the first things they bought StackRox for. When I was over there, they have tons and tons of apps, and it was really hard for them to visualize it, and they needed to visualize it and stop it. So go ahead to the next one. And then the final use case that I'm going to talk about is regulatory compliance. So regulatory compliance, there is a bunch out there. IBM SoftLayer, they wanted to get SOC 2 compliance for their deployment of SoftLayer. They actually needed to use StackRox for it because getting compliance, like I mentioned earlier, on a container is not useful. I need to say to the auditor, as of Monday, we ran a check and your deployment or your application is completely compliant in these checks, and then I ran it again on the next day, and here's my evidence. So the biggest thing for compliance is, can you show evidence that all the things that are in that control are done, and I can continually check it so I don't have to do it manually. Because the orchestrator is moving things around, and that container might live an hour, it might live a minute, it might live 2 days, there's no way you can manually do it. Human beings, they can write some tools, maybe you could write scripts to do it. I've heard of companies try to figure this out. You need something that just does an automated check and make sure it's compliant, and they can describe it, put it out there. Now, you might have a tool that does compliance checks on your containers that are running. That's totally fine, but it's not going to give you the deployment picture. And without the deployment picture, you're never going to be able to get compliance. You may do benchmarks to say we're Center for Internet Security. Everyone familiar with Center for Internet Security benchmarks like CIS? Like typical. There's two ones that you need to care about in a cloud orchestrated work environment. There is the center for, there's the Docker, and there's the Kubernetes. So when you're talking to people and they say, hey, we're going to go cloud native, we got an orchestrator, we're doing this, say, okay, are you compliant with Kubernetes and Docker? Now, if you're not on Kubernetes, Pivotal is now going to be Kubernetes. I mean, everything's really going to be Kube, some sort of Kube workflow. We cut short for Kube. K8s, Kube, Kubernetes. These are the 3 words that the industry uses. So K8s is the letters, it's the 8 letters with an S, right? So it's K8s. When someone comes to you and says, we're running this, the first thing you should say is, our posture is, are you sysbenchmark for Docker and Kube? And if they say yes, then sure, show me the report. They go, we don't have the report. Okay, we'll figure out how to get me a report, and then we're gonna make sure that we're there. That should be a continual thing that you need to ask for, and always there. The other ones are your type of business. So if you're a healthcare and there's health information there, I don't want to be HIPAA, which is obvious. If NIST is one, NIST 800 is a lot of people have to run into this one. Manufacturers. Johnson Controls just lit up their customer I got in December. NIST is a big one for them, right? Because there's controls running there. They're heating this room right now a little bit too hot. And then the PCI is another important one. And there's other ones that are out there, but these are the ones that we see over and over again. When we talk to people, they're always asking, do you have PCI compliance? Do you have NIST? You know, what do you have? And so all you have to take away from this is ask the question. Show me where my deployments are compliant and show me which deployments need what, right? So I need to understand what those deployments are. And if you go to the last slide, so that's it. So a little summary. We talked about vulnerability scanning, policy control, native network segmentation, right? And then compliance. So in terms of, there's some products up here that can do these things. These are not all the products. These are just things that are top of mind. CrowdStrike is a very small part of it. They can do the runtime. They can put their agent and do the threat hunting part of it. But you would still need something like Sysdig or StackRox to describe your deployment, right? So threat hunting on a container is one thing, but I want to be able to find, sure, that's bad, but what application did that affect? I need to know everything about that application. So really, you need to start with something that describes your deployment so that you can do stuff with it. So I'm going to pause here. Actually, you can flip to the last one. Questions from anybody? Sure.
How about SOX compliance?
SOC compliance. So SOC 2 or one of those?
SOC.
Sorry. So, okay. Not all of it is going to apply to your workload, right? So what you would do is, what some customers do is they'll take all the controls, they'll get a spreadsheet of all those evidence, and they'll just filter on the ones that would be applicable to them, right? So that's what SoftLayer did for their SOC 2 compliant. They took all of the controls as a feed and continually ran it, and they just picked the ones they needed for SOC 2. Because SOC 2 is a subset of some of those that run. But you need to have some sort of tool with it, right? And think about it, that same compliance on a running server, not a lot of it applies to it, but the things that apply to it, you need to make sure you do. So that's really the hardest thing. Does that help answer your question? Okay. Any other questions?
I can see integrating some of the security operations.
Sorry?
I can see the cloud integrating the security operations.
Oh, integrated with cloud, okay. So the question was, how do we see this integrated with security operations, right? SOC. Word SOC 2, SOC is on there, okay. So the way it's integrated with the operations is you need to have some sort of, so first up, Amazon has great, Microsoft, Google, they have great feeds that come out of these. So you want to have some sort of feed to go in, and it's usually a SIM, some sort of SIM. A lot of the cloud providers for security are providing their own feed that you can tap into. So like CloudTrail with Amazon, you know, one of those. You want that data to be feeding into whatever tool you're using. So there is one of the SIMs, not Splunk, it was Sumo Logic. They built a whole Kubernetes dashboard. At AWS reInvent, they unveiled their big dashboard for any workload that's running in the cloud. They have a dashboard that flows into that. Your SOC would take that dashboard and they would run it. But really it's telemetry, and telemetry is how people are getting that. So there's some open source tools like Grafana and others that people are running. Elk Stack would be like an open source kind of like raw, they would get it, kind of competitor to a Splunk. We see the SaaS providers are running some sort of open source tool. The enterprises are running something like Sumo Logic or Splunk. They're all doing the same thing. They're just feeding data to the SOC. Does that help answer your question? Okay. Any other questions?
Kind of feedback on that. Have you seen like, or do you even have like TCPs for like some of the things that are going on, especially when you have to integrate with existing tools? Because as a security person, from what you just said, now I have to do CI/CD talk. You know, my CISO or my bankers, they have to know like, hey, well, this is what the containers are now doing.
Yep.
So, yeah, I need to have a high level. You also have to tell them like, okay,
how do I do it?
Other things that we're doing, and how do you measure it?
Yeah, how do I do it? How do I measure it? So There is, if you're in a cloud workload, there's a great deal of help for you to do these kind of integrations. A lot of times they're built in. Everything is normally integrated in a cloud native environment with webhooks. So webhooks is how everything is these days are integrated. And everything is API driven, so it's much easier to do this than what we used to do. It's just webhook, API, get a token, and now I'm integrated with it. So it's not as hard as it used to be. It's actually, the kind of cool thing is that you get better security in an orchestrated environment than I got in a monolithic. The reason it's better is I can stop somebody from going forward if they don't do what I want them to do, because I have control over what's happening, and it's standardized. Whereas in a monolithic, everything was all over the place and it was hard, right? So now everything's API and webhooks, and so that would be the way those integrations happen. But there's a ton of really good help now to how to integrate this stuff out. So like the CNCF website has literally workshops that how to teach you how to do this stuff, and so it's easy to learn those things there. But the best way to do it is like to find a partner that knows that. So like Fishtech's doing DevOps, and Brian's in the back there. There's people that are really good at this now. There's a bunch of companies that are just specializing in just demystifying that for you and going, here's how it works. And so those are the easiest ways to kind of figure out how to bring those into your environment. But you're right, there is some new words you're going to have, new vocabulary, that kind of stuff that you're going to have to learn about.
Well, and follow-up then, how has other companies been receptive to that? It's like, all right, we're now over budget because now we have to send our team members, or we have to hire this third-party consultant.
Yeah, well, it's offset though. On that first slide I showed you, your cost is dramatically to go down. If you have an on-prem cloud workload, you're going to be spending 5 times less on average on the servers and the environment. So everything's going to get smaller. You'll save some money, but you will have to do some tooling. Once you get there, it'll be actually better. Security is easier in a cloud native than it was when it's all over the map. So you'll end up normalizing, but there's going to be a period of time where, yeah, you're going to have to do some. Change is expensive, right? So anytime we change, and that's just part of life. And so that's why people are not moving all their apps right away. That's why they're picking and choosing. A lot of companies, their strategy is greenfield. Any new application we get, we're going to make sure it's cloud native. Any old apps we're going to let die on the vine, and when they're not needed anymore, we'll replace them with something else. That's kind of what I've been seeing people do.
Tom, can I act from a CISO's perspective on the use cases Tom provided? When I look at that, I think of, the problems that we have from a development perspective, our software developers, is getting them to make sure they do source code scanning, they're addressing vulnerabilities in their software, all those different things. With the policy use case and the compliance use case, think about it. I can actually set up policies and say, okay, first developers, you have to, do your work in dev, and you got to move it to test, right? Before you can even move it to prod. Oh, by the way, if you don't get a passing score from the vulnerability scanner and your source code scanner, it won't get moved to prod until you fix all those issues, right? From a security perspective, I'm forcing them, right? Which is great, because right now it's a battle, because they're going to tell you all different kinds of stuff. If you get all that stuff agreed upon with executive management up front saying we want to release stuff that's vulnerable or weaknesses in our software, and they're going to agree to it, and what recourse does the developer have, right?
I call it avoid Groundhog Day, which we just had. I've been doing security for 30 years now. Every day is Groundhog Day, right? They did it again. They find it. We go find the person that did the egregious thing, or we tell them not to do it again, and then a new person gets hired and they do it. And so what this removes is the Groundhog Day from our security. Now our security becomes security as policy, security as code, not security as do it and we'll be mad at you if you don't do it, right? Which is really all we could do when we didn't have active control. So the word in my mind that I always talk to customers about is, do you have active control over your process? Your process from building to deploying and running, do you have active control over it? Doesn't matter how you have it, just can you stop it, by policy? So it's a good point to Mark's point.
Okay, I think we have time for one more question. Anyone? One more question?
Murphy, nothing?
I know there's pieces of paper around here with questions on them, just in case no one asks any good ones. So,
I think we have some good ones.
So continuing on the webhooks then, is that something that you're seeing built in? Is it built into the overall ecosystem? Is it built into the different phases? And
All
are you
cloud.
seeing- Is the scanning and stuff like that automated, that when you hit a certain phase?
Yeah. So a cloud native app would support webhooks. So if you ask the question, kind of like are you using cloud native in your approach, it will support through API webhooks, right? But in terms of integrating with the scanners, it all depends on what path you choose for your cloud workload. So if you're going to go down the Microsoft path, they have a scanner that's built in and you can just use it. instead of having to build your own or integrate your own, right? If you, some companies will build their own open source Kubernetes inside and then Amazon EC2 instances. Now they own it. They may be running it on the cloud, but they own that management of it, right? So then they're gonna have to get their own open source tool and they're gonna have to integrate it and make sure it works. And so what I'm seeing a lot of enterprises do is they go, you know what? We want to make it pretty simple for ourselves. We're just going to use Amazon, or we're going to, you know, have Rancher or someone manage that for you, and then you just focus on the apps instead of focusing on the how to make all that work.
So if you go to Amazon, you're saying like, we're gonna go with Amazon EKS, we're gonna go with all those.
So EKS would be a Kubernetes-based orchestrated workload. So that would be EKS, Amazon. Yep.
So that's what the organization is saying, like,
Yep.
we're gonna follow up the services here.
Yep. So I'll meet with people. My last meeting at Stack Rocks was an organization that had 10,000 nodes running in a Kubernetes environment, a cloud environment. So there are some massive environments out there. We're going to have, in this room, we're going to have, you know, 50 nodes or 200 nodes, like GE Transportation, they're running 200 nodes, right? It's not that big, but it's still a lot. That's servers just to run their environments, right? So it's not going to be that large, but in your Amazon, that would be servers. So think about in your mind spend, right? How much does 100 servers cost me a month to run in Amazon? If I move my application from monolithic to cloud, now I need maybe 5 times less to run that same amount of horsepower because I've modernized my application. So that's kind of the difference that people are looking at. If you had an existing infrastructure and I modernize that to make that cloud native and hybrid it, I'll have to use 5 times less servers than I used to use. So now I'm regaining, you know, or maybe I have more horsepower now, maybe I can do more. So a lot of companies are frustrated that they built a lot of infrastructure and they have to abandon it for cloud security. Cloud security can be cloud security in there, but it also can be hybrid, and there's a lot of hybrid out there. A lot of the stuff from Google and all of them is managing your workloads on-prem and in the cloud, and the clouds are now managing that stuff for you. So there's a new thing from Google. I think Amazon announced it at Invent. They're all going to say, hey, give us all the money and we'll manage the stuff on-prem and we'll manage stuff in the cloud, and that's what's happening now.
So you guys are just now embarking on both talking about vulnerability, and are you talking about the idea of like running probes with health checks and like this probes?
No, vulnerability of the software packages in our image repository. So there's a library. So every company that's going to run in a containerized workload or orchestrated environment, they have to have a library of deployments or applications that are, they're like deployments, they're called images. That image is basically a file that describes when you go to deploy this, I want you to grab this piece of software, this piece of software, this piece, and build it all together and run it as an app. The vulnerabilities of those pieces of code, those pieces of software is what we're scanning. Those are the vulnerabilities we're looking for. Once it's running, we use different vulnerability. We call it threat hunting or we call it runtime security. It's different. The kind of things we do when it's running is we'll take the process and we'll normalize it and say this is the only thing that should be running in this application. If somebody inserts a new process, we can say we didn't tell that to happen, so that must be a hacker and we need to stop it. It's a threat.
Those are like the health checks we were talking about.
Those are the health checks, yeah.
Per day that we produce and show that.
It's real time, so you need to just say, here's my real time threat hunting that's automated and it's always looking for that stuff because the second it happens, you want to stop it. In a Kubernetes environment or in an orchestrated workload environment, we can actually stop it before the hacker runs the command. So we can detect it and we can stop them from running the shell before they even run it, notify the SOC, to your question earlier, immediately, then the SOC or the security team can go all up to developers and say, fix your build and redeploy. So we don't fix the application anymore, we stopped it, we tell the developers, hey, take this piece of software out, it's a vulnerability, then they'll redeploy the app.
Or you can just kill it and then just reproduce it.
If you kill it, which is how we do it, it's still in the build, that vulnerability, and so you want to, that's the iterative DevOps, that's why there's always this figure 8. We found something, we stopped it, now I want to fix it so it isn't in there to be used again. Right, that's kind of how we do the security now.
Is maybe the upper face here, the YAML file,
YAML files, yeah.
That's protecting at a point here.
That's just network, that's just firewall,
That's
right?
not
You can't go
process,
here. Yeah.
not more granular.
But that's not, at the kernel, I started running something that is a crypto mining currency, and I want to stop that. How do I know they did it? I need to have stuff that's continually looking at those kind of threats.
Yeah. Hey, I think that's good for tonight. So, yeah, just a couple things before we break up here. When Tom and I were talking about this in November, setting this up, you know, I had no idea what a container was, I'll admit that. And I'm a CISO, so that explains half of it. I thought it was going to be a good discussion. This was a great discussion. So this is definitely setting the bar high for what we want to do here as a group going forward. So just continue to follow us. So anyone who hasn't followed us on LinkedIn, do it. You know, there's a ton of good pictures out there tonight, I imagine, because Jaman here loves taking pictures. The other thing is, how many students do we have in here? One? Two, excellent.
I'm always learning.
So, and he's still active
Different kind of
student.
student.
So we have 2 students. I want this number to grow exponentially. So, you know, anyone, you guys go and talk to your peers and get more students out here. And just for you two, this right here is a great selection of the security organization and community here in Detroit. So take the next half hour and mingle with as many of these people as you can, because this is a great group right here. And I am totally impressed by the number of people that showed tonight. This is great, so keep coming. And so, what is it, next month we have the executive track, right? So just a different take. So here, we do like a technical track and then we do an executive track. Executive tracks are meant more for like the CISOs and the executives, but we want everyone to come and join so that you understand the things that we're dealing with. The technical tracks are more like tonight, where we'll dig down into the details and hopefully get you a new perspective on things. But thanks for the engagement, thanks for showing up, and really appreciate it. And join us on LinkedIn, and we'll see you next month.